So this video is going to help you guys out with our Pythagorean expectation problem. We're going to look at regular season baseball numbers here. Your guys' project is going to be with regular season in the NFL, so football. So the win percentage formula changes just a little bit. So it's runs scored squared instead of the 2.37 that football uses, all over runs scored squared plus runs allowed. Notice the parentheses on the bottom. If you don't group those two together on the bottom, you're just going to divide runs scored squared by runs scored squared and then add this on there. So we got to make sure we group those together. So here's some Excel shortcuts for you. So the two divisions I picked are the AL Central with my team Detroit and the NL West with your guys' team Colorado. So here's their wins and losses, runs scored and runs allowed for 2011 season. Some shortcuts. If I want to figure out their win percentage, baseball plays 162 regular season games. So if I come up here, if I say equals, I grab the win and I divide it by 162. And I hit enter, it'll give me 54%. Shortcut, so I can drag this all the way down and it'll fill it in for me for all the other teams. So we don't need this one, there's no data there. So if you click here, they took B7, so Minnesota's wins divided by 162. Okay, so there's one shortcut. Now we want to actually go do this Pythagorean win percentage. We don't have to do this for all of them, we only have to do it once and drag it, because that's the power of Excel. So what we want to do is fill in this formula. So equals runs scored, and we need to square this, so we got to go exponent squared. Now we're going to divide it by, the key is you got to put a parenthesis in there for this formula. So we're going to grab runs scored, we're going to square it again, and then we're going to add on runs allowed, and we're going to square it. Okay, and we hit enter. So that's what their Pythagorean win percentage should be, based on runs scored and runs allowed. Now, same idea, we can just drag this all the way down and it'll fill it in for us, for all the other teams. Now, just go delete this one, there's no numbers to actually do anything here. So if you go here, what they did for San Fran, they took E9 squared, so they took San Fran's runs scored squared, divided it by runs scored squared plus F9 squared, so runs allowed squared. Okay, now to find the number of expected wins based on this formula, we need to take their win percentage and multiply by the numbers of games that they played. So equals this cell times 162 games that they played. Okay, now again, we should just have to drag this down, delete this one, and there you go. So based on the runs scored and runs allowed, Detroit should have won 87.5 games. They won 88. Okay, so to find the difference here, we're going to say equals what happened minus what was expected. So they had a difference of half of a game. So basically, they performed exactly how they should have based on their runs scored in 2011. So we drag this all the way down, and get rid of this one, and then we can see what happens. So Chicago, for instance, they underperformed by 4 games based on what they scored. So they scored more runs than Detroit, and they allowed about the same. So they should have won 89 games. They only won 85 for a difference of this. Okay? So now you can look at this and say, okay, Detroit was exactly what they should have been. This is an unlucky team by 4 games. They underperformed by 1 game. Okay? Cleveland, however, based on what they did, they gave up almost 200 more runs than they scored, but they won 6 more games than they should have based on this Pythagorean formula. Okay, and you can look the same way down here. So San Fran overachieved in the division. Arizona underachieved in that division there by 5 games, and Colorado underperformed by 4 games as well. So now that we have the win percentage, expected wins, and the difference for each team, we want to look at who is lucky and who is unlucky. Now this is going to be a little bit different than your guys' NFL one, because all the NFL ones are going to be in one big order together without any spacing or anything. So you're going to want to look at the differences when you do the NFL one and figure out who is minus whatever and who is positive whatever. So what you can do is you're going to have to click kind of a cell, in what we want to sort. So you don't have to sit there, they'll sort these for us. So I'm going to click like this cell right here, or even this one here. You come up to data up top, go to sort, and it'll come here and it'll say column sort by. Okay, I want to sort them by column I, which is the differences. And I want to go largest to smallest, hit OK. Now it only did this division up here. It didn't do this division down here, but your guys' NFL one will. So now when I sort them, notice it took the team with it too. So Cleveland was the luckiest team. They overperformed by about 6 games. Detroit was about even. Kansas City minus a game. Minnesota minus a game. Chicago unlucky by, minus 4 games. So it sorted those for us. So when you guys do that in your NFL one, you'll sort them. You'll be able to look and go, okay, these teams are lucky. These teams are unlucky, and you should just be able to count them. Now, another thing you can do if you're trying to count teams, let's say I just highlight these. If you go look at the bottom, it'll tell you the count. So let's say, you want to highlight a bunch of stuff and you don't know how many cells that is. Like, let's say we highlight all of these. Down at the bottom, we'll say count is 10. It'll actually do average and sum for you, but those don't mean anything to us right now. Okay? So there's some shortcuts for using Excel for your Pythagorean expectation project. Good luck with that and have some fun.